Hello and welcome to Lesson 4 in Unit 5, Solving Quadratic Equations in our Grade 10 Academic Math class. So this is the fourth and final lesson in Unit 5, and it introduces the concept of the discriminant. Now, what's cool about the discriminant is we've already been exposed to it when we started talking about the quadratic formula. So this lesson starts with a recap of the possible numbers of solutions that we could deal with or that we could find when we're solving quadratic equations. So the first one is right here. We have a couple of parabolas that are crossing over. So it is entirely possible that we might arrive at two solutions for a given quadratic equation, that if you were to model it like a quadratic relation would look like this. It's possible that we could be dealing with only one solution per quadratic equation. And it's also possible that there would not be any x-intercepts here. Our parabolas either opening up with a vertex above the x-axis, or our parabolas opening down with a vertex below the x-axis. So it's entirely possible to have two solutions, one solution, or no solutions. So this particular lesson on the discriminant addresses the fact that sometimes when we're asked to solve a quadratic equation, it might be nice to know exactly how many solutions there are going to be before we solve it. So we have a tool to do this, and like I said, it links back to the quadratic formula. So here is our quadratic formula. That is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, given ax squared plus bx plus c equals 0. So that's our quadratic formula. The discriminant is the part that's under the radical or square root sign. So that's this little piece. Let me just tidy this up. This is our discriminant right here. All the stuff that's under the radical sign. B squared minus 4ac is a discriminant. And what we do is we use the discriminant to become a predictive tool. It will help us determine how many solutions there are going to be, whether it's 2 or 1 or 0, depending on what particular values using the discriminant results in. So let's start, well, there's the discriminant right there. And we're going to work through a few examples and sort of see how it plays out. So there's our discriminant, b squared minus 4ac, and we're going to do 3 different equations and see the 3 different results that come from using the discriminant. So let's start with 4x squared minus 2x minus 3. So here we have our a value of 4, our b value of minus 2, and our c value of minus 3. So let's write out our discriminant. So the discriminant is b squared minus 4ac, and we are going to substitute in the a, b, and c values from this equation. So b squared, that's going to give us negative 2 squared minus 4 times a, which is 4, times negative 3, which is c. Now we're going to evaluate that. Again, I'm a fan of the old calculator here, so we're going to go with negative 2 squared minus 4 times negative 3, and that's going to give us 52. So our discriminant here, d equals 52, that's going to tell us something. So that's our first one. Let's do all the calculations first, and then we'll examine sort of what the discriminant tells us about the number of solutions. So let's work our second example. That's going to be 5x squared minus 12x plus 9 with a, b, c values of 5, negative 12, and 9 respectively. So let's get our discriminant happening again. That's going to be b squared minus 4ac. And we're going to substitute again. So negative 12 squared minus 4 times 5 times 9. Let's ask our calculator to do the hard work here for us. So that's going to be negative 12 squared minus 4 times 5 times 9. That's going to equal negative 36. So this time our discriminant is going to be equal to negative 36. And let's work our final example. So our final example is x squared minus 2x plus 1 with a, b, c values of invisible 1, negative 2, and 1 respectively. So let's work the discriminant one more time. So b squared minus 4ac. So we're going to substitute in. That's going to give us negative 2 squared minus 4 times 1 times 1, and that's going to give us 0. You can put it into your calculator, but it's going to be 0. So this time we have a discriminant equal to 0. Okay, So the next thing that we're going to do, and if I were teaching this in class, we would break out Desmos and we'd have a look to see what these particular graphs look like. But these graphs, if we were to graph them, this would result, our first example would result in there being 2 roots. Our second example would result in there being 0 roots, and our third example will result in there being 1 root. So if you're interested, you can actually just take those 3 equations that we've done, you can drop them into Desmos, graph them, and have a look just to prove what I've just told you is true, that the first equation has 2 roots, the second equation has no roots, and the third equation has 1 root. And this will help us draw patterns. So let's have a look at these 3 values and then compare them to the number of roots. So if we have a discriminant that's 52, what we notice is that that d value is greater than 0. So that's a number larger than 0. And that will correspond to 2 roots. What we notice about the second equation is our d value is less than 0. It's a negative number, which will result in no roots. The third example, where the discriminant is equal to 0, is going to result in 1 root. So depending on the number you get, you can predict the number of roots for a given quadratic equation by using the discriminant. Now we have a little summary down here, and this says that if our discriminant is greater than 0, it's going to be 2 real solutions. If our discriminant is less than 0, there will be no solutions, and if our discriminant is equal to 0, there will be 1 solution. So I know we just did this above, but it's so much more dramatic in class when we can look at the graphs and make these discoveries, but it's just not necessary. I can just tell it to you and then you can believe me or go look at Desmos to see that I'm right. Okay, so now we move on to actually using the discriminant. So we're talking about using the discriminant. The type of phrasing we use when we are talking about using the discriminant in a question, the question will prompt you to determine the number of roots without solving or graphing. So basically not rearranging or square rooting, factoring, using the quadratic formula, or graphing. It wants to know basically the prediction of the discriminant. So let's go through these examples here. So our first example is x squared minus 4x plus 3, where we have an a value that's equal to 1, a b value that's equal to negative 4, and a c value that's equal to 3. So let's substitute these into the discriminant. So the discriminant, as we know, is b squared minus 4ac. I don't think I said it above, but sometimes students will bring the radical sign into this. The radical sign is not a part of the using the discriminant. It's the numbers and I guess the values under the radical sign that we're interested in. So let's do some substitution. We have d equal to negative 4 squared minus 4 times 1 times 3. And let's ask our calculator to do that. Well, that will be 16 minus 12, so that's going to be 4. So how do we summarize this? Well, we notice that since the discriminant is greater than 0, we can say that therefore there will be 2 solutions. And this is the type of logic we want to employ here. A since statement. Since we make a judgment on the discriminant, so since the d value is larger than 0, therefore we then make the associated prediction. There will be 2 solutions. Let's try our second example. So negative x squared plus 2x minus 3 equals 0. Again, it's important to note that all 3 terms must be on the same side to use the discriminant the same way they need to all be on the same side to use the quadratic formula. So let's get our a value. That's going to be negative 1. Our b value is going to be 2. And our c value is going to be negative 3. And let's substitute into our discriminant. So d equals b squared minus 4ac. And now a substitution. So that's going to be 2 squared minus 4 times negative 1 times negative 3. So that's going to be 4 minus 12, so that's going to be negative 4. So let's set up our thinking. So since the d value is less than 0, therefore there will be no solutions. All right. So when might we use the discriminant? The discriminant can help us determine the number of solutions. So for example, if you're being asked to solve a quadratic and you're using it in a word problem to try to figure out the particular values, it might be beneficial to know in advance whether you're talking about one solution or two solutions, or whether or not you should bother to try to solve it at all, because maybe there are no solutions. So that's one opportunity to use the discriminant. The second way that we can use the discriminant, and that's it down here, is for finding the best method for solving a quadratic equation. So here's a little bit extra. If b squared minus 4ac, so if our discriminant is a perfect square, we should solve by factoring. And if our b squared minus 4ac is not a perfect square, then using the quadratic formula is the way you want to go. So I'm going to continue this. I realize the lesson's getting a bit long. I'm going to do these last couple examples here in part 2, and then you're off for homework. So I will see you in part 2.